Hello everyone. Good morning. Good morning. Yes, good morning. Okay. Now today we will see the point chemical cell in electrochemistry. Now what is meant by chemical cell? The cell in which there is an actual redox reaction. Actual redox reaction. That cell is called as a chemical cell. Electricity is generated from spontaneous redox reaction. In chemical cell, we already know two half cells are different. A cell consists of two half cells. From that, both the half cells are made up of different material. Then it is called as chemical cell. And this chemical cell is again classified into two groups. One, chemical cell with transference, and chemical cell without transference. Now what is meant by chemical cell with transference? In this cell there is a porous partition, porous spot or salt bridge between two electrolyte solutions. Two different electrodes are dipped in two different electrolyte solutions. For example, zinc rod dipped in zinc sulfate solution. We are taking zinc rod. Here zinc sulfate solution. Zn 2 plus ion containing electrode. Okay. Now another electrode is a, suppose, copper rod dipped in copper sulfate solution. Here copper rod is dipped in copper sulfate solution. Zinc rod dipped in zinc sulfate solution. And these two electrodes are connected through external circuit, and two electrolyte solutions are connected through a porous partition. There is a porous partition between two solutions. Okay, this is the construction of chemical cell with transference. Example, how will you represent it? Zn is in direct contact with Zn2 plus ion solution, aqueous solution. Zinc is in solid state. There is a porous partition. Indirect contact. Single vertical line indicates direct contact. Double vertical line indicates indirect contact. Indirect contact between Cu2 plus solution in aqueous state, in which copper rod is in direct contact. Now here Zn goes in the solution as Zn2 plus ions, leaving behind electrons, that's why it is negatively charged. Here copper 2 plus ions from solution deposit by withdrawing electrons from that electrode, hence this electrode is positively charged. And always where oxidation takes place, return to the right, reduction takes place, return to the left. This is the representation of this chemical cell with transference. You can take another electrodes also, Zn2 plus Fe2 plus Fe, or aluminum 3 plus Ni2 plus Ni. You can take any electrode, but there should be a porous partition or porous spot or the indirect contact between two solutions. Then it is called as a with transference. Why it is called with transference? In this cell, since Zn rod zinc electrode is going in the solution as Zn2 plus. Means here positively charged ion concentration increases. That's why to balance that charge on the solution, the electrons are transferring, this material is transferring, ions are transferring through this porous partition. That's why it is called as a chemical cell with transference. Why it is called chemical cell? Two different electrodes. There is actual chemical reaction. With transference, there is a transfer of ions through this porous partition or porous spot or even through salt bridge also. That's why it is called as a with transference. Okay. Now we will see the reaction. At anode means the electrode where oxidation takes place. What reaction is taking place at this anode? Zn goes in the solution as a Zn2 plus 2 electrons. This is the oxidation reaction. At cathode, reduction takes place. Cu2 plus ions takes 2 electrons. These electrons are traveling through the external circuit and forms Cu. This reaction is a reduction reaction. Now what is the net cell reaction? Net cell reaction, addition of these two up cell reactions. Electron get cancelled. Therefore, net cell reaction is Zn plus Cu2 plus forms Zn2 plus Cu. This is the redox reaction. Okay. Now, what is the reaction question for this reaction? QA. Reaction quotient. Activity of product upon activity of reactant. Activity of product means activity of Zn2 plus into activity of Cu divided by activity of Zn into activity of Cu2 plus. But activity of any metal in its pure state, in its standard state like solid copper or solid zinc, it is considered as unity. Activity of copper is unity, activity of Zn is unity. Therefore, QA is equal to activity of Zn2 plus upon activity of Cu2 plus. Okay, this is the reaction quotient. Now, according to Nernst equation, what is the Nernst equation? What is Nernst equation? E cell, here we are considering complete cell. E cell is equal to E naught cell minus 2.303 RT upon NF. This is the general Nernst equation. Log of QA. Now put the values of QA, you will get the required equation for EMF of this particular Daniell cell or chemical cell with transference. Suppose concentration of Zn2 plus or activity C1, this activity C2, whatever may be. Therefore, E cell is equal to E naught cell minus 0.0591 upon 2. This quantity 2.303 RT upon F. This value is 0.0591 at 298 Kelvin temperature. If we take temperature constant at 298 Kelvin, then the value of 2.303 RT upon F will be 0.0591. And here N, number of electrons transferred per ion, 2. Therefore 2. And log of QA reaction quotient, activity of Zn2 plus upon activity of Cu2 plus. Okay, this is the Nernst equation for particular Daniell cell. Or if we put C1 and C2, it will be, instead of this activity of Zn upon activity of Cu, we will get C1 upon C2, whatever may be. Now if we change the electrode Al3 plus Ni2 plus Ni, then also write the cell reaction, write the value of Qa and put the value of that Qa in this Nernst equation. You will get a required equation for cell potential. This is about chemical cell with transference. Okay. Now we will say chemical cell without transference. There is no transfer of ions through this porous partition. Such cells are called as a chemical cell without transference. Now we are considering here chemical cell. Chemical cell means two electrodes are different, two half cells are different, okay, but there is no transfer of ions through porous partition. Such cell is called as a chemical cell without transference. Chemical cell without transference. Now how will you construct it? Chemical cell means two half cells are different. Yes, two electrodes are different. They are made up of different material. But there is no transfer of ions through porous partition. Then how will you prepare this electrode? Two electrode materials are different, but there is no transfer of ions. For that purpose, without transference, in that case, mind well, you have to take only one electrolyte solution. We are not taking here two different electrolyte solutions. We are taking only one electrolyte solution. For simple examples are there. For example, if we consider an electrolyte solution of HCl, we are taking electrolyte solution of HCl. In that HCl solution, both the electrodes are dipped. In same electrolyte solution, both the electrodes are dipped. One is reversible to cation, other is reversible to anion. Okay, means here for cation, reversible to cation, the cell will be H2. We are using gas, hydrogen gas. That's why you have to take platinum for making electrical contact. Okay, platinum H2 H plus. Here H plus from HCl. This is the one half cell, and another half cell is reversible to Cl minus ions. Reversible to Cl minus ion means you can take AgCl, Ag, sparingly soluble salt electrode. You can take sparingly soluble salt electrode for this side. Okay, this is the construction of this chemical cell without transference. Mind well, here you are dipping both the electrodes in same electrolyte solution. That's why there is no transfer of ions. There is no presence of two different solutions. There is no transfer of ions. That's why it is called as a without transference. And why it is chemical cell? Two different cells. Here hydrogen electrode, here AgCl electrode. And there is no transfer of ions. Both the electrodes are dipped in same electrolyte solution. Okay, next part is same. Write the cell reaction. Here H2 undergoes oxidation, 2H plus 2 electron, or you can take half H2, gives H plus electron. From both sides, if we take H2 or half H2, then last equation will be same. Okay, this is the oxidation of hydrogen. Now here what happens? In case of AgCl electrode, there is a reduction of Ag plus ions from AgCl. Ag plus ions are there in AgCl. These Ag plus ions takes electron, forms Ag, while Cl minus ions remains as it is. This is the cell reaction at anode and at cathode. This is anode reaction. This is cathode reaction. At anode, oxidation takes place. At cathode, reduction takes place. Now, what is the net cell reaction? What is net cell reaction? Addition of anode reaction and cathode reaction. Okay, addition of anode reaction, half H2 plus this AgCl, electron get cancel, gives Ag plus H plus Cl minus. Okay, this is the redox reaction. It is called as a net cell reaction. Now from that net cell reaction, what is the QA? Reaction quotient, activity of product upon activity of reactant. If material is in standard state, solid state, we take activity as a unity. Okay, then in product there is a activity of H plus into activity of Cl minus into activity of Ag divided by activity of AgCl into pressure of H2 raised to half. In case of gases, we have to take partial pressure. Now, if we take pressure of hydrogen as a 1 atmosphere, activity of AgCl, solid AgCl will be unity. Activity of solid Ag will be again unity. Therefore, QA is nothing but activity of H plus into activity of Cl minus. And from that, you can write the equation for EMF according to Nernst equation. What is the Nernst equation? E cell is equal to E naught cell minus (2.303) RT upon NF log QA. Therefore, E cell is equal to E naught cell minus 0.0591. Why 0.0591? At 298 Kelvin, and N number of electrons transferred will be 1 into log of activity of H plus into activity of Cl minus, or you can take activity of HCl. Okay. Now, what is this E naught cell? E naught cell is the E naught right minus E naught left. Standard EMF of right side minus standard EMF of left side. E naught AgCl minus E naught hydrogen electrode. Okay. E naught cell is equal to E naught AgCl minus E naught H2H plus. Now hydrogen electrode potential is considered as a 0. Therefore, E naught cell is nothing but only E naught AgCl. Hence, you can replace this E naught cell as E naught AgCl. Okay. Now, instead of using this electrode, you can take another different types of electrodes. For example, instead of I will take only HCl as a electrolyte solution. Okay, what happens here? instead of taking AgAgCl, you can use as like platinum H2 gas HCl. We are using same electrolyte solution. What is the condition for chemical cell without transference? The solution should be same. One electrode reversible to cation, other electrode reversible to anion. Then you can take here Cl2 platinum. Hydrogen gas electrode, chlorine gas electrode. This chlorine gas electrode is reversible to Cl minus. Similarly, you can prepare different types of chemical cell without transference. For example, I will give examples. Suppose we use solution as a ZnSO4. If we use aqueous solution, electrolytic solution as a ZnSO4, then what is the anode? Oxidation takes place, is reversible to cation, Zn. Zn goes in the solution as Zn2 plus ion. Okay, now another electrode should be reversible to this SO4 ions. Here we will take a sparingly soluble salt electrode like PbSO4 Pb. This PbSO4 is a sparingly soluble salt. Take a lead electrode. On that lead electrode, PbSO4 is deposited and it is dipped in ZnSO4 solution. Another zinc electrode is dipped in ZnSO4 solution. This will form a chemical cell without transference. Similarly, instead of PbSO4, you can use Hg2SO4, Hg platinum, mercurous sulfate electrode. The condition is that we have to consider the electrode reversible to cation and other electrode reversible to anion. Similarly, we can construct different types of chemical cell without transference. This is all about chemical cell with transference and chemical cell without transference. Once you write the cell representation, you can consider its reactions: oxidation reaction at anode, reduction reaction at cathode. From that two half cell reaction, consider a or add these two half cell reaction to form a net cell reaction. And from that net cell reaction, redox reaction, write the value of reaction quotient. And this QA value is substituted in Nernst equation. We will get the equation for potential of that particular cell. Okay. Thank you. In next lecture, we will see the concentration cell. Okay. For that purpose, you have to subscribe my channel so that you will get notification when next lecture is online or delivered. Okay. Thank you.